Okay, I'm going to show you the construction of a 120-degree angle. Again, very simple, quick and easy. Start with a straight line. We're going to construct a 120-degree angle. Let's say we'll make it right there. Grab our compass and we mark off one very large circular arc around the outside. Next, go back to our original point here, using the same size arc, mark off arc number 1. Putting the point where those two arcs intersect, mark off the second arc. Now, if we connect the original point and the second arc this time, we have successfully made a 120-degree angle. How do you propose that we might make a 45-degree angle? Well, if you've been paying attention to the previous lessons, we've already learned how to construct a right angle, and we've learned the process of bisecting an angle. So of course, to make a 45-degree angle, we're simply going to construct a right angle upon a line and then proceed to bisect that angle. So let's commence. Step 1, start with a straight line. Step 2, make a right angle. Let's select a point. Let's mark off two equal arcs, one to the left and one to the right. Increase the size and mark off arcs above. Connect these to the bottom point, and of course we've just constructed our right angle. There we go. Right, reducing the size of the compass, to a more reasonable dimension, we're going to mark off two arcs, one on the bottom line and one on the vertical. From those 2 points of intersection, I mark another two arcs out in space, one there and one there. Pencil and ruler, and the final step. Connect, and what have we made? We have made a 45-degree angle. Another very easy construction. To make a 30, we're simply going to bisect a 60. Let's start again with the 60-degree angle construction. Mark a point. Mark one large arc out into space. Go back to this beginning point, put the compass point there, mark off an equal arc, and we've pretty much finished our 60-degree angle. Might as well mark that in. There's our 60 degrees. Now I can use these 2 points, this one down here, this one up there. I can use those two as my starting point for another 2 arcs out in space. Mark one arc out there, mark another arc here, and there's my bisection complete. Grab the ruler, grab the pencil, and voila, we have our 30-degree angle. Okay, we're about to make an equilateral triangle, another simple, very easy to construct shape. Let's say we have a line of some length. I'm going to make an equilateral triangle using that as one of the sides. I simply set the compass so that it has the same length as that line segment. Extend it out till it matches in length. Looks good. Make one large arc to the top. Putting the point here at the other end, make a small arc. We've now got the vertex of our triangle. If we connect that point to the base on the right, and also to the base on the left, we have our completed equilateral triangle. 1, 2, 3 equal sides, and 3 equal angles of 60 degrees. Complete. Is it possible to construct a triangle given the side lengths 4, 5, and 7 centimeters? Let's find out. Start with the longest measurement. Longest one's going to be 7 centimeters. Measure that line somewhere within my frame. 7 centimeters. Now, I'm going to use my compass and the ruler and set it to one of the other two sides. In this case, I'm going to go for 4 centimeters. A little too long. Probably a bit easier if I draw the length of 4 centimeters on my page, just over to the side, and try and set my compass to that line. And we're nearly there. There we go, 4 centimeters. Going to go to one end of my 7 centimeter base and just construct an arc up in space. It may or may not be short or long enough. I'll soon find out. Then the other measurement, I've already taken care of the 7. That was the base, 7 centimeters. I've got the arc of 4 taken care of. Now an arc of 5. Again, a little easier, just to mark that side length on paper to 5 centimeters and try and set the compass to match that. There we go, 5 centimeters. To the other end of my 7 centimeter base, mark an arc. It is indeed possible to make a triangle with sides of 4, 5, and 7. This side here is going to be 4 centimeters. And the other side is going to be 5 centimeters. So we've successfully constructed an accurate representation of a 4, 5, 7 scalene triangle.